Hey guys, Jacqueline here, and welcome to part 10 of how to make a 2D RPG in Unity. In this video, we'll be finishing our inventory by allowing the player to drop items from their inventory. Let's jump right in. First, let's talk about how this should work. Let's say that our player has picked up 4 carrot seed packs, and they've been added to their inventory. The player then opens their inventory to see the carrot seeds. Then the player decides that they picked up too many carrot seeds and they want to drop one of them, so the player presses the remove button on the slot. The remove button will call a function on the inventory UI script that will then tell the inventory to remove the carrot seed from the slot that triggered the remove call. This will remove one of the carrot seeds from the inventory. Then the UI should refresh to update the quantity text on the slot, and if needed, the icon image should also be updated. Then, with the UI updated, the carrot seed pack should be instantiated back into the world. We can also add an effect to make this look like it was dropped. Now that we know what we want to achieve, let's get started. Hey guys, Future Jacqueline here. While I was working on creating the video, I changed the name of the setup function to refresh. I hadn't realized that I did this until I was helping some of you out on your inventory UI. So before we do anything else, we will need to change the name of the setup function to refresh. Open up your inventory UI script and scroll down to the setup function and click on the name of it. Then hold Command on Mac or Control on Windows and press the R key twice. This will let us rename the function, and Visual Studio will also rename all of the references to it. Now that that's fixed, we can continue. To begin, let's open up the inventory script and scroll down to the add function. We're going to add a remove function below our add function. But to remove an item, we first need to know which slot we are removing the item from. So we will need to add a parameter to the function that tells us which slot to remove the item from. To add the function, we can say public void remove, and then in parentheses we can also add our parameter. Since our slots are in a list, they can each have an index within the list. The first item has an index of 0, and the second item has an index of 1, and so on and so forth. So we can use an integer to indicate which slot index we want. Great, now that we know which slot we want to remove the item from, we can let the slot know that it needs to remove an item from it. Scroll up to the slot class and add the remove item function under the add item function. This function does not need any parameters. We only want to remove an item if there's an item to remove, so that means we should check to see if the slot is empty before we attempt to remove items. In the remove function, let's use an if statement to check if the count is greater than 0. If it is, then there's at least one item in the slot. Inside of the body of the if statement, we can remove one of the items from the inventory by subtracting 1 from the count. Once we removed one of the items, we should check if there are still any items left in the slot. We should do this because there's a chance that there was only one item in the slot, and by removing it, it's caused the slot to become empty. If the slot is empty, then we need to remove the icon and set the type to none. So let's use an if statement to check if the count is equal to 0. If it is, then we can set the icon to null and the collectible type to none. Save the script and scroll down to the remove function. In the remove function, we can now call the remove item function on the slot. To do so, we can say slots@index.remove item. Save the script and let's open our inventory UI so that we can call the remove function on the inventory. In the inventory UI script, scroll down to the refresh function. After the refresh function, let's add a new public function called remove. This function is going to be called when the player presses the remove button on the slot, so we'll need to know which slot is calling the function. We will have the button pass us an integer, which will indicate its index. In the remove function, let's call the remove function through the inventory. Let's say player.inventory.remove and pass the slot ID into the parentheses. Then let's refresh the UI by calling the refresh function. Great, let's save our script and head back to Unity to set up the remove button on the slots. With Unity open, navigate to the prefabs folder and open the slot prefab. This will open the prefab editor. If you don't see the prefab editor, make sure that you're in the scene tab. Then right-click on the slot object in the hierarchy and add a Text Mesh Pro button to the slot as a child. Then select the button and resize it to fit in the slot. I'm going to resize mine to be 20 by 20 so that it's a nice square. Then I'm going to move the button to the top right corner of the inventory slot. We're going to click on the graph in the rect transform. This is going to open up the anchors menu. We're going to hold down the option button on Mac or Alt on Windows and click the top left corner anchor. This will set the anchor to be top left, but it will also move your button to the top left of its parent. Okay, now that we have our button where we need it to be, let's go ahead and change the text on the button. Let's set the text to be in uppercase X, and let's make sure that the text is auto-sizing. Let's add an on-click event to our button by scrolling down to the button component in the inspector and clicking on the plus in the lower right corner of the click event section. We can't set up the on-click event in the prefab editor, but this will allow us to set it up on all of the buttons in the scene. Let's save and exit the prefab editor. To make things go a little faster, let's delete all of the slots after the first one in the hierarchy. Then let's drag the inventory game object from the hierarchy into the newly created spot. Let's select the remove function from our function dropdown list by navigating to inventory_UI and then to remove. This will create another new field that is filled in with a 0. On this slot, you can leave the number alone. Then let's duplicate the first slot, filling the inventory back up with all of the slots we deleted. We did this because unfortunately there isn't a faster way to add an on-click event to all of the buttons at one time and set them up. All we have to do now is set the slot ID on each button. So skip the first slot and select the second one. Select the remove item button and set the slot ID value on the on-click event to 1. With that one set, we need to make our way through all of the slots remove item buttons, setting the slot ID to be 1 more than the slot ID before it. For example, the first slot ID is 0, the second one is 1, the third one is 2, and so on and so forth until all of the slot IDs have been set. Then let's fix the inventory UI script. Because we deleted our slots, we need to fix the slots list. A lot of our slots are missing except for the first one. So let's set the size to 0 and then lock the inspector. Then we can drag all of our slots onto the list, making sure to unlock the inspector when we're done. With our slots all set up again, we can test it out. Save the scene and hit play. While playing, walk into a carrot seed and then open the inventory. The UI slot should be updated with the item icon and the quantity like it was before. Now press the remove button on the slot and the icon should disappear and the quantity text should be set to an empty string. Hooray! We've successfully removed an item from the inventory by interacting with the UI. But now the item is gone forever, never to be seen again. I don't really think that this is fair, so we'll drop the item back onto the ground when we remove it from our inventory. To drop the item, we're going to need a way to associate our collectible prefab with the collectible type. We need this because once we pick up the item, we take all of the information from it and then delete the instance of the prefab. We lose all reference to the prefab. But if we had a way to check which prefab should be spawned based off the type of item it is, then we could spawn the prefab back into the world. Let's create an item manager to keep track of which prefabs are associated with which item type. Navigate to the scripts folder and create a new C# script called item manager. Double click it to open it. With the script open, we can delete the start and update functions as we won't be using them in this script. What we're going to do is create a dictionary. A dictionary is like a list, but it holds key value pairs. This allows us to associate one data type with another. In our case, it lets us associate the key, the collectible type, with the value, collectible prefab. Create a public collectible variable called collectible items. This is going to be an array. This array will hold all of the prefabs of our collectible items. Now we can create our dictionary. Our dictionary can be private as we won't need to access it from anywhere outside of the script. We can say private dictionary, and then in angle brackets we'll define the types that will be allowed in our dictionary. First is the key. The key type will be collectible type. The second value is our value type, and that will be set to collectible. Let's name our dictionary collectible item dict, and let's set it equal to a new dictionary. Now that we have both our prefab array and our dictionary, we can set up the dictionary. Let's do that in the awake function. Add an awake function to the script, and in the body, we will loop through all of the prefabs in our collectible array. I'm going to use a for each loop for simplicity. For every item in our collectible items array, we're going to need to add it to the dictionary. So let's create a function that will do this for us. After the awake function, create a private void called add item and have it take a parameter of collectible named item. Then we should check if the item is already in the dictionary. We can do this with an if statement. In the if statement, we should check if the collectible items dict does not contain the key item.type. If it doesn't already have that key, then we can add the key value pair to the dictionary. In the body of the if statement, let's say collectible items dict.add, and in parentheses, the first thing will be the key, item.type, and the second parameter will be the value, item. Awesome! Our dictionary is now set up. And now that we have a dictionary, we need a way to get an item based off of the type it is. So let's add a public function right after our add item called getItemByType. This function is going to take a parameter of collectible type, and let's call it type. Inside of the body of the function, we should check if the dictionary contains the key. We can say if collectible items dict.contains key and then pass in the type. If this is true, it does contain the key, and we can return the value at that key. We'll say return collectible items dict bracket key, close bracket. But what should we do if there's not a key of this type? Well, we should return nothing or null. Now that we can get our item, we need an easy way of accessing this function. So let's save our script and head back to Unity. I'm going to add a reference of our item manager in our game manager. The game manager is a script that will handle the game states and important game information. So it's an excellent place to store the item manager. In the hierarchy, let's right click and add a new empty game object and call it game manager. Then navigate to your scripts folder and create a new script called game manager. Then drag the script onto the game manager object in the hierarchy. Let's also remember to set our transformed position to be 0, 0, 0. Then we can double click the game manager to open it. With the game manager script open, delete the start and update functions because we won't need them. In the game manager, we're going to be using a singleton design pattern. In a singleton design pattern, only one instance of the class is allowed to exist in the game at any given time. The reason that we're going to be using a singleton design pattern here is that we only want to manage the game once. If we have more than one instance trying to manage the game states, things can get messy and unexpected behaviors can occur. This way, we can be sure that everything will happen when we want it, the way we want it. There are many ways to implement a singleton design pattern, but we'll be doing so by creating a static reference to the game manager called instance. Whenever a game manager instance is created, we'll then check to make sure that it's the only one, and if it isn't, then we'll delete one of the instances. Let's add an awake function to the script. In the awake function, we'll use an if statement to check if instance does not equal null and instance does not equal this. If that's true, then an instance already exists. In the body of the if statement, let's destroy this .gameObject. But if this is not true, then we need to set the instance. So add an else statement and inside of the body, set instance equal to this. We also need to make sure that the game manager is never destroyed by loading a new scene. We want to make sure that the game manager follows us around until we quit the game. To do this, after our if statement in the awake function, we can say don't destroy onload and pass in this .gameObject. Perfect! Now that we have our singleton game manager, we can add our reference to the item manager. After the instance variable, create a public item manager called item manager. Let's then complete the reference in the awake function after the don't destroy onload. I'm just going to put the item manager on the game manager object so we can get it by getting the get component from this game object. Now that we have an easy way to access the item manager, we need to make sure that it's all set up in Unity. Save the script and head back to Unity. Once Unity is open, we can select our game manager game object from our hierarchy. Then let's drag our item manager script onto the game manager. The item manager has an array for collectible objects, so let's go ahead and set that up now. Let's navigate to our prefabs folder and drag our collectible into the collectible items array on the item manager. With that set up, let's head back to our inventory UI script. In the inventory UI script, scroll down to the remove function. Let's add a local variable to hold the collectible item that we need to drop. Then, to get this item, we need to call the getItemType function on the item manager. We can access the item manager through the game manager. So we can type GameManager.instance.itemManager.getItemByType. Now we need to pass in the type, which we can get from the slot in the inventory. So to access the slot, we will need to say player.inventory.slot at the slot ID.type. Now that we can get the item that we need to drop, we should check to make sure that it's not null before we do anything with it. Under the item to drop reference, let's add an if statement to check if the item to drop does not equal null. If the item to drop does not equal null, then we can remove the item from the inventory and drop it. So copy and paste the code after the if statement into the body. Now that we can get the item that we need to drop, we need a way to actually drop it. Let's do this in the player class. Save the inventory UI script and open up the player script. In the player script under the awake function, let's create a new public function called drop item, and let's give it a parameter of the prefab we need to drop. Before we can drop anything, we need to know where we're going to drop it. Create a vector2 called spawn location and set it to the player transform.position. If we drop the collectible in the same space as the player will pick it up as soon as it spawns. This is not what we want. So we need to add a spawn offset so that the collectible doesn't spawn inside of the player's collider. Let's choose a random float between -1 and +1 for both the x and the y. I'm going to create a local variable called randx and set it equal to random.range with the min value of -1 and the max value of +1. I'll do the same thing for the y value, calling it randy. Now that we have the random values for x and y, we need to create a position vector for them. Create a new vector2 variable called spawn offset. Then set it to a new vector2 with randx for the x value and randy for the y value. Then, for good measure, let's normalize the vector. Now that we have a new position to spawn the collectible item in, we can spawn the item in by saying instantiate. Then we'll pass in 3 parameters. The first parameter is going to be the item that we want to spawn. The next parameter is going to be the location that we want to spawn the item at. So let's set that to our spawn location plus our spawn offset. And for the rotation, we don't really care about the values, so we'll just add quaternion.identity. This is just going to use the rotation of the item prefab. Nice, we have successfully spawned the item back into the world. But I want to add an effect so the drop looks a little bit more interesting. I want to add a little bit of force to the item so that it slides across the floor. So to do this, we're going to use physics, which means we're going to need access to the rigid body on the collectible item. At this point, the collectible item doesn't have a rigid body on it, so we'll need to add one. We should also add a reference to it in the collectible script for easy access. Save the player script and head back to Unity. In Unity, navigate to your prefab folder and select the collectible item. In the inspector, add a rigid body 2D to the collectible. Then make sure to set the gravity scale to 0 so it doesn't fall off the world when we play. Let's also set the rotation on the Z to be constrained. Then let's open the collectible script, and at the top of the script, let's add a public rigid body 2D variable called RB2D. In the awake function, we'll set RB2D equal to getComponent rigid body 2D. Let's save the script and head back to the player script. In the drop item function, let's also save a reference to the instantiated collectible item. Before we instantiate it, let's add a collectible type and name it dropped item and then an equal sign. Then after we instantiate the item, we need to give it a little push. We can say dropped item.rb2d.add force. The force that we're going to be using will be the spawn offset vector, and then we should multiply that by a speed. I'm going to just make it a default 0.2 right now. Then we should set the force mode to impulse. Setting the force mode to impulse will apply an instantaneous force to the item, pushing it pretty fast. If we don't change the force mode, then the force will be applied over time, and the force won't have as great of an effect on the push. So save the script and then head back to the inventory UI script to finish the remove function. In the remove function, before we remove the item from the inventory, we need to call player.dropItem and pass in the item to drop variable to the function. Save that and then head back to Unity. Once you're back in Unity, hit play and test it out. You should be able to open and close your UI, pick up items and see that they've been added to your inventory, and then drop items from your inventory and see them in the world. When I play, I notice that the collectibles are pretty slippy, and they're also tend to kind of spawn in the player's collider still, so we need to fix that. Let's head back to the player script and fix the spawning code. Instead of getting a random value between -1 and 1 for the x and the y, I'm just going to pick a random vector by using random.InsideUnitCircle. I'm going to multiply this by a number to make sure that the radius of the circle is bigger than 1. So I'm going to do about 1.25. You can adjust this number as big or as small as you need just by multiplying by some decimal number. Great, everything else should be the same. Let's save and head back to Unity. Let's also make a couple of changes to the collectible rigid body as well. In the inspector, I'm going to bump the mass up to 2, and then I'm also going to increase the linear drag so that it will slow down and come to a stop. So I'm going to set the drag to be 0.75. Feel free to mess with these numbers until it works for you. Then let's save and try again. I think that this looks a lot better. We now have a working inventory. Good job on all of that hard work. Thank you so much for watching. Don't forget to like this video and subscribe if you aren't subscribed already. And if you like these videos and want to know when more will come out, go ahead and hit that notification bell. I'll see you guys next time.